Hi there, welcome to our weekly math TPs again for A Math. Our previous Sec 3 A Math lesson we covered on roots as well as the three conditions of roots being not real, equal, as well as two distinct real roots. So today we're going to look at a question that's a bit different when the range of values, right, actually ends up being a quadratic equation. Okay, so let's see what happens here. So just a very quick recap before we tackle this question. All right. So notice that we have the three conditions, b squared minus 4ac more than 0. This will be for two distinct roots. We have b squared minus 4ac equals to 0. This will be for equal roots. And last but not least, we have b squared minus 4ac less than 0. This will be for no real roots. All right, so as usual, we will attempt to rearrange our given function first. So here we have 3kx squared plus k minus 5x, okay, equals to 5x squared plus 2. So we will attempt to make the right side 0 first, bringing it one step closer to the quadratic form. Okay, plus k minus 5x minus 5x squared minus 2 equals to 0. All right, let's factorize the x squared term from 3kx squared as well as minus 5x squared. So when we do that, we have 3k minus 5 close bracket x squared plus k minus 5 x minus 2 equals to 0. So our a term, okay, will be 3k minus 5. Okay, let me just zoom in a bit to this part. And our b term will be k minus 5. And our c term will be negative 2. So applying our b squared minus 4ac, this question says that the roots are not real. So the condition will be b squared minus 4ac less than 0. So let's sub the value in. Right? Let's expand k minus 5 squared. Okay, let's also expand this term over here. Okay, let's further simplify. Okay, and group items together. Okay, once we have done all these, right, this time around we have a quadratic inequality here. So we can first solve for the roots of the inequality first before we actually carry on. So we can either use the formula if we want to, or we can factorize it using the cross product method. Okay, so I will attempt to use the cross product method for this. So here will be k and k. We want a positive 14, so we'll go with a 15 and a negative 1. Right? So factorizing this, we have k plus 15, k minus 1, less than 0. A common misconception among students is that they will just apply the sign to both. But this is incorrect. Okay, this is incorrect. Just because their product is less than 0 doesn't mean that individually they can be less than 0. A good example would be you can take a positive number, multiply by a negative number, and you still get a negative number. So it shouldn't both be negative. All right? Okay, so what we're going to do here is that we have to draw something called the number line. Okay, and we will include the roots of these two equations in it. So we have negative 15 here and 1 here. Okay, these are the roots of our equation. All right. So with this, checking the coefficient of k squared, it is a is more than 0. So it's going to be a U-shaped graph if we were to sketch it out. Okay. So if it's a U-shaped graph, let me tie this up a bit. Maybe I'll just do it this way. Okay. Then I'll adjust my points. All right. So from here, less than 0 will mean that we are looking for this portion of the graph. Okay. So our k values will be found between negative 15 and 1. And this will be the range of values of k. All right. Okay, so just to give a few more examples, if they're asking for more than 0, we will be shading these two portions instead. Okay, and our inequalities will be separated into two. All right, this is for the case whereby if the question's condition is k plus 15, k minus 1 is more than 0, then we'll look at the portions of the graph that are above the axis. This is a separate question type. All right, so I hope this video has been helpful. As usual, do check out our products and our guidebooks, and feel free to follow us on any one of these social media. All right, have a good day ahead.